Hey guys, welcome back. We had conferences yesterday, but it's nice to be back here, back in school. We've got a new group of students today with our Pod B, which is fantastic. It's great to have you guys here in person. And I wanted to kind of like remind you that as we start quarter three or quarter four, make sure that you're doing all the daily things. These little things every day really do matter. Like they make a difference. Today we're going to do one more note card. We've done a lot this week of note cards. Usually we only do like one, maybe two a week. This week I think we're on our third one. So it's a pretty busy week in terms of content. And one of the reasons is we're going to be taking some tests next week. So I kind of want to get some of these note cards completed so that we can keep practicing these skills next week when I might not have as much time to teach you. I thought we'd do more of them this week. So the questions we're going to do today, or the thing we're going to do today, is solving an equation with two steps. And we talked about two steps equation, I think, on when we looked at the bags and coins problems on Tuesday. Those were two-step equations. And this is more like saying, what's your process for solving it when you don't have a picture, right? So the bags and coins were a picture. This is like, how do we do it if we don't have a picture? And the key word here is isolate. I wrote that down, isolate. And I'm not sure if you know what that word means or if you've seen it. It's a strange looking word, but isolate means to get something by itself. So when we isolate, we try to kind of find a way to get something by itself. And in this case, the thing we're going to find or get by itself is the variable. We want the variable to be all by itself. So we're going to isolate the variable, right? And remember the variable, I think you guys know this now. The variable is going to be the letter, right? So if we have an x, we want the x by itself. If we have a y, we want it by itself. If we have an n, we want it by itself. So isolating the variable or isolate the variable is really important. And here's how we do it. The first thing we're going to do to isolate the variable is to remove the constant or move the constant. So move the constant, okay? And this usually means the constant is the thing we know. So in our bags and coins problems, the constants were the coins. We know what the coins are worth. If we had like 4 coins on one side, we know it's worth 4 coins. We didn't have to say how much is each coin worth. It's like, no, it's just 4 coins. What we didn't know was the bag. So the first thing we want to do is move the constant to the other side. I promise not too much more writing, to the other side of the equation, but we don't have to write that. And the second thing we're going to do, number 2, is we are going to divide. So it's almost always division, but we're going to divide I'm sorry, let me fix that. We'll just say divide. Let's just say divide and let's get into it. Divide, we're basically going to divide the coefficient out. So we're going to divide out the number that's with the variable. So I'm going to show you how to do this. And the first thing we're going to do, let me change my color. You guys know I like to change the colors around here. Let's go back here. The first problem I'm going to do with an example is 4x. Okay, please write this down as I go. 4x plus 3 equals 23. Okay, this is going to be our first one. Now, in this case, we have the different parts. We have the variable right here, the x, right? We have the constant, which is what we know. We know what the 3 is. And we have another constant over here on the other side of the equation is the 23. So we have that. Now, if we were going to draw this with bags and coins, the 4x would be represented by 4 bags. And the 3 constants would be 3 coins. And on this side, we'd have 23 coins. Now, when we did the bags and coins problems, we eliminated, and this is our first step, move the constant to the other side because we want the variable, the x, to be alone. So if I want to make this x blue, just so you recognize like this is our variable, we want that to be all by itself. So we're doing almost the opposite of order of operations. Like instead of doing a multiplication and division first, in this case, we want to get rid of the variable or the constant first. We want to get rid of that 3. So how do I get rid of positive 3? Well, I go minus 3. And what do I do? Well, it's kind of like taking away the 3 coins. Remember I talked about keeping everything in balance the other day? If we're going to take 3 away from one side, right, we've got to take 3 away from the other side. So to keep them in balance, we have to take 3 away from both sides. So what we're going to do is we're going to subtract 3 from both sides. Okay? And our first step then, as you can tell right here, I'm going to write this down. Our first step is to subtract, right? So please write that down. And then we're going to rewrite the problem. So I'm going to rewrite what we had. And I think I used this color, right? We're going to bring down the 4x. And we're going to look at that plus 3 and minus 3 and know that it goes away. That's gone. We're going to bring down our equal sign. There's no reason to write the 0 because once we eliminate it, that's the whole idea that we took it off the scale, like we don't have it anymore. And over here, we're going to say 20. 23 minus 3 is 20. And now step 2, this is why it's called a two-step equation. Step 2 is to divide. And when we divide, we want to basically get that x all by itself. So how do we make it so that that x is alone, or that x is only standing by itself as just a single x? It means we got to get rid of the 4, right? Because 4x means 4 times x. So what we're going to do now is we're going to get rid of the x by dividing by 4. And if I divide 4 by 4, I get 1. 1x, that's what I want. So I divide by 4 on both sides. Because remember, an equation, just like when you work with fractions, an equation means to keep it in balance. If we do it on one side, we do it on the other. So now we rewrite the problem, and we are going to say 4x divided by 4 would give me just 1x, right? This would just be x. And I could say 1x, right? That's fine too. 1x equals 20 divided by 4, give me 5, right? So then this answer is x equals 5. So in this case, I can just get rid of this 1. I don't really need the 1. The 1 is the same as 1x, right? So my answer is x equals 5. And then the last thing I want to do is I want to check it. So let's check it and make sure we're correct. Oh, I'm sorry. I got to go back and change my size. It always changes the size for some reason. I don't like that. Do the check here. Okay, so we're going to check this. We're going to say, okay, well, check. This is always good with equations. You can always see if you did it right. We're going to go 4 times 5. Remember, I'm plugging in the 5 plus 3 equals 23. And I look at that and I say, well, 4 times 5 is 20. 20 plus 3 equals 23. And that's correct. Like I can look at this right now and say, check. I got this. This is it. So that means my answer is correct, right? So we've figured out how to do this with 2 steps using isolating the variable. Move the constant to the other side, which is almost always going to be done with subtraction when we first start out with a lot of these problems. And then we divide. Second problem we're going to do. Let's do one more practice one. Should we do this one? Same color. Let's stick with, let's make it orange. Just make it all bright and colorful. Next one's going to be 8y. I'm going to use a different variable, by the way. 8y plus 7 equals 31, right? So what do I do here? Let's go back to our black and say, well, first step was always to isolate the variable. The variable is my 8y. How do I do something to get rid of it? Well, I get rid of the constant. I subtract the 7 coins. If I have 7 over here, I take away 7 from both sides. I draw my line, right? This is my subtract step. I rewrite the problem. So back to my orange. And I say 8y, which didn't change at all. 7 minus 7 is 0. Don't write anything. There's no reason to write the 0. And 31 minus 7 would give me 24. Now, what's great here is most of you now are like, okay, I know the answer to this one. Like 8 times 4 equals 24. Just like over here, 4 times something equals 24 times 5. But what the process is, what you're actually doing, the second step, and some of you are doing the math in your head, but the second step is to actually divide, right? You're trying to get the y all by itself, so we divide, and there we go. All right, so we divide by 8. So remember our steps. I said the first step is often going to be subtraction, right? And the second step is going to be division, right? Subtract and then divide. I didn't write that over here, but that's what we were doing. All right, now let's go back to my orange. Take a look at this. 8y divided by 8 would give me 1. 8 divided by 8 is 1. 1y, the y stays, right? Equals 24 divided by 8 would give me 3. So this is y equals 3. 1y is the same as y. So I could say in this one, y equals 3, if that makes you feel better, or you can just leave it like it was. And let's check this one. Let's check this one with red again. So we'll come down here a little lower on my page. We're going to check it. It's always good to check with algebra, even if you're pretty sure. It's nice to check. Let's do 8 times 3, because we said y was 3. I'm sorry, plus 7. I've got to change that. All right, plus 7 equals 31. We just started with that same equation, and I plugged in that 3 for y. 8 times 3 gives me 24. 24 plus 7, does that equal 31? And if you're thinking math-wise, like 6 plus 24 would give me 30, plus 1 more would give me 31. So you say, yeah, that totally works. Like 31 equals 31, right? That's the whole point here. And then we got it. And that's a two-step equation. So we're going to practice this over the next couple of days and into next week. But I wanted you to see it here and have it in your notes. So try to make sure that you copy this note down pretty carefully and keep it in order. I think it's really important that you keep things lined up in order, because this is a process where when the problems get more complicated, it makes a huge difference whether you're staying organized. Right now, these problems you might be able to do without being organized. But once we go down the road a little bit, they're going to get more complicated. And I think being organized will really help you out. All right, kids. Once again, this will be our third note card this week for sixth grade. That's a lot. So make sure you're taking pictures of each one from your notebook, or all together. You can take them all together if they're all on the same 2 pages, and submit them in the note card document by Friday. And I hope you guys have a great day today. Excellent. Bye, guys.